Okay, let's have a look at this problem. Design a discrete bipolar perceptron classifier network to achieve the classification of the planar patterns illustrated in the figure. Both shaded disjointed areas A and B on the figure belong to category 1 and the rest of the pattern space of the plate belongs to category 2. So you can see two shaded regions and both of them are disjointed. They are not joined. Okay, so you have region A, this is region A and this is region B. So you have two regions A and B, and so if at all a point lies in this particular region A, or if at all a point lies within this region B, then it is said that it belongs to class 1. And if at all the point lies anywhere outside this region, anywhere it may be, then those points are belonging to class 2. So we need to design a classifier using bipolar discrete perceptron which will do this particular classification. So how will we be going about this particular problem? Again, we have to come back to the equations of the lines. So there are some lines which are shown here which will be dividing the entire pattern space. Now how many lines are dividing this pattern space into different regions A and B? If at all you look at region A, if we have a look at region A, there are 4 lines which it is a square sort of a region. So there are 4 lines which are the bounding lines. And the region which is bounded by these 4 lines belongs to class 1. So which are those lines? If at all this is one line, this is another line, this is the next line, and this is the next line. So there are 4 lines, and whatever region lies to the right hand side of this line, the left hand side of this line, above this line and below this line, this region is belonging to class A, class 1. Similarly, I have 2 different lines, that is this one and this one. So this is a sort of a rectangular region, and this is also bounded by 4 lines. Now remember that this and this line is the same, it is a continuation of the line, and also this line is the same. So altogether how many lines we have got is we have got 6 lines, and these 6 lines will be giving rise to these 2 regions A and B which are belonging to class 1, and the rest of the pattern space belongs to class 2. So I will have in total 6 equations. So I shall name the lines. I can name the lines as O1 to O6. So first I shall draw the lines O1 to O6. The lines are already drawn in red. So I have drawn this particular line. I am drawing the lines once again, and I will name this line as O1. Similarly, I will take this line and name it as O2. This line I name it as O3. This one O4. This one O5. This one O6. So I will just draw the lines in red so that you are able to differentiate. Okay, it may not exactly be along that particular point. Okay, then next here, so how many lines we have altogether is we have got 6 lines altogether. So it is very, now this is very simple. The equations also will turn out to be very simple, but sometimes you may not get so simple equations for the lines. So we shall write the equations of these lines also. Okay. So these 6 lines are there. Now what are the equations of these 6 lines? So we have for O1, equation for O1, I will be writing it as in this way. Okay, so O1 equation is nothing. Where is O1? Here. So this line is parallel to the x2 axis, and whenever the line is parallel to the x2 axis, the equation is nothing but O1 is equal to x1 minus 1.5 is equal to 0. So I can write it as x1 is equal to 1.5. So this is the equation of the first line. Now we would prefer to write the equations in this particular form and not in this particular form. We would prefer x1 minus 1.5 is equal to 0. So always it should be equated to 0. Please remember this because it is better to write in this particular form. Now what happens is that x1 minus 1.5 is equal to 0. Now this equation is fine, but this equation gives the equation of this particular line here. So this line equation is that. But I do not want the equation of the line alone. I want the equation of the area which is there on this side. And that, so because I am interested finally in this region. And for the point to be in this region, it has to be on the right hand side of the line O1. It has to be on the left hand side of line O2. It has to be above line O6 and below line O5. Only then it will be in this particular region. Am I clear? So how will I come to know whether I should take, now there are two options for me. One is x1 minus 1.5 is greater than 0 or x1 minus 1.5 is less than 0. Because x1 is equal to this equation, x1 is equal to 1.5 and x1 minus 1.5 is equal to 0 is for this line. But if at all I want to see the area which is on the right hand side of that particular line, then I have to select either this one or this one. Now which one will I select? If at all I go with my common sense, I think I should select this one. X1 minus 1.5 should be greater than 0 because it is on this side. It is on this side and this side is a greater than side. But if at all you are still not sure, you can take any one point which is to the right, that is we'll take 3 and substitute in this equation. So 3, so here I can write 3 minus 1.5. It is equal to 1.5 and yes, it is greater than 0. So what do I come to know? What should be the equation of the line which I have to consider? It has to be this one, that is this equation, and not this one. Is that clear? So similarly for the other 6 lines also you have to do the same procedure. I am explaining to you for only one particular line, but the same thing you'll have to do for 6 lines. But you need not write this in the formal steps of the problem, but you have to analyze it before you take this particular part. Is that clear? So I will just rewrite this. So I have written this for the region on the right hand side of line 1, x1 minus 1.5 should be greater than 0. Okay. So we have done for line O1. Similarly, we have to do for line O2. So let's write for line O2. For line O2, it is different. The region should be on the, now the equation of this particular line O2 is nothing but x1 is equal to 3. That is nothing but x1 minus 3 is equal to 0. This is the equation for line O2. Similarly, what is the equation for line, since we have started, equation for line O3 will be x1 is equal to 4 and equation for this line will be x1 is equal to 5.5. Now I write it in this particular way, so it is x1 minus 4 is equal to 0 and this is x1 minus 5.5 is equal to 0. Now we'll take all these lines together, that is line O2, O3 and O4. Now if at all you see for line O2, we are interested in the region which is on the left hand side and not on the right hand side of the line. So what will happen is that for line O2, O2 is nothing but x1 minus 3 is equal to 0. But the region we are interested in on the left hand side, so I write x1 minus 3 should be less than 0 because this region. So if I want, I can take this particular point 1.5 as x1 and I substitute here as 1.5 minus 3. 1.5 minus 3 is minus 1.5, which is less than 0. So it is satisfying this particular condition. Is that clear? Similarly, we can find the equations for the other lines also, that is lines O3 and O4. So we'll write for line O3, what should be the equation? The equation should be O3 is nothing but x1 minus 4 is equal to 0. But now I am interested in the region towards the left hand side, towards the right hand side again. So because it is the right hand side region, I write x1 minus 4 is greater than 0. When we come back to line O4, we are interested in the region towards the left hand side, that is this side, and not this side. We are interested in this side region. So for line O4, the equation will be x1 minus 5.5 is equal to 0. So you write x1 minus 5.5 should be less than 0. So these are the four equations which we have got, depending upon whether it should be on the left hand side or on the right hand side. Now we switch on our focus to the lines O4 and O6. So I shall just erase this whatever is written here. So that we can go for line O5 and O6. So for line O5, we take for line O5, I am judiciously using the board, but you all can write one after the other. For line O5, we are interested in this region that is below that particular line. So what is the equation? Equation is nothing but x2. Equation of this line is nothing but x2 is equal to 3. So when we write, we shall write it as x2 minus 3 is equal to 0. Now we are interested in the region below. So below means usually it will be x2 minus 3 is less than 0. Am I clear? If at all you are not satisfying, you take any point which is below this particular line. So below this line you can again take 1.5 and substitute here. But this is x1. You take this 1.5. x2 is equal to 1.5. So when x2 is equal to 1.5, minus 3 is nothing but minus 1.5. So it is less than 0. So we come to know that it satisfies this particular condition. So, and for line O6, the equation of the line O6 is x2 is equal to, here, if at all you want me to write here, x2 is equal to 1.5. So x2 minus 1.5 is equal to 0. And I am interested in the region above that particular line, above this particular line. So it will be x2 minus 1.5 greater than 0. This also you can verify by using a point. So finally we are left with these 6 equations. Which are those 6 equations? I shall just, this is equation 1, this is equation 2, this is equation 3, this is equation 4, this is Okay, again, although I call them equations, they are not equations. Okay, so these we are left with these 6 equations. But finally, when we are now there is a problem here. What is that particular problem? Is that we are interested in this particular regions. Now, wherever it is x1 minus 1.5 is greater than 0. Now all these things are fine till now we want to design a neural network. So there is something that we have to use a change of sign. Okay, so whenever I write this particular equation, I have to use change of sign. Now what you have to do is that, now this particular procedure is done. Now what is the main procedure is that wherever you will see that there are 3 equations when the sign is greater than 0, greater than 0, greater than 0, and there are 3 equations which have got sign less than 0, less than 0 and less than 0. Now what do we have to do for these equations? Whenever we are designing a neural network, we will be using these direct equations. We will be using this equation, we will be using this equation. We will not be using these inequalities. We will have to use the equations. That is, wherever the equal to sign is present, this is an equation. This is an inequality. So we cannot use the inequalities. So how will you convert inequalities into equations? Now, for these 3 conditions, it will be proper. That is, but for these 3 conditions, wherever I use less than sign, it will not be proper. So what is to be done in this case is that three equations, wherever there is less than sign is used, we have to slightly modify those equations. And how we will be modifying those equations is just change the sign of those equations. So how we will be doing that is that we shall change the sign of this equation, and what we will do, minus x2 plus 3 is equal to 0. So this will be the final equation which I will be using. Similarly, for this one, this is done, this is proper. This is proper, which I will be using x2 minus 1.5 is equal to 0. This is proper for O6. For this one, I cannot use, so I have to change the sign here and write it x1 plus 5.5 is equal to 0. And this one, I will have to write it as, I have to change this and write it as minus x1 plus plus 3 is equal to 0. So finally we get 6 equations. Which are those 6 equations? This is for O1, this is for O3, this is for O2, this is for O4, this is for O6, this is for O5. Sorry, not this. These are not for O1 and O2. For O1 and O2, it's not these ones, but these ones. This one. And okay, something got it disappeared. This one and this one. So we have 6 equations with us, and we shall go with those equations. So I shall rewrite all those equations. All 6 equations I am writing here. So these are the 6 equations, and based upon these 6 equations I will be drawing my neural network. So based upon these 6 equations the neural network will be drawn. So I just okay, if you all have any difficulty in how to get these equations, I have already explained to you about it. If you all still have, you all can ping me. Okay. Now we shall draw the neural network. Now while drawing the neural network, how many of these neurons are there? There are 6 neurons, O1 to O6. So I shall be drawing a neural network with 6 neurons. So I draw one, okay, I'll draw a bigger circle, O1, O2, O3, O4. So we have drawn 6 neurons here. Now each of these neurons is O1, O1, O2, O3, O4, O5 and O6. So these are the 6 neurons. And how many inputs I have? I have got 2 inputs. One is X1, other is X2, and the third one is a bias which I will put as 1. Now for the first one, that is O1, I have X1 minus 1.5. So I take it X1, what is the weight? 1. And from the bias I take, what is it? Minus 1.5. Similarly for O2, I have minus X1 and plus X3. So X1, when it goes here, the weight has to be minus 1, and when 1 goes here, the weight has to be 3. Am I clear? Next we go to O3. O3 is X1 minus 4. So X1, the weight is 1, and here the weight will be minus 4. Similarly for O4, it is minus 1 and plus 5.5. So it is minus X1. So I will write it as minus 1 here. And this one, bias, it will be, the weight will be 5.5. Similarly for O5. Now O5, it is minus X2 plus 3. So minus X2 meaning the weight will be minus 1, and this will be plus 3, and O6 it will be 1, this is minus 1.5. Am I clear? Now, so this is not done. This is not done. Why? Because finally the combinations we have to take, and in order to get 2 regions, there are 2 regions which are there, 2 disjoint regions which are there, and in order to get those 2 disjoint regions, we have to go back to the diagram. When we go back to the diagram, what we can see is that the disjoint regions, one region is made up of what? Combination of O1, O2, O5 and O6, and only when all of these conditions are satisfied, it will be coming in this particular region. Yes or no? Only if it is greater than this particular line, less than this particular line, above this particular line and below this particular line, only then this particular condition will be satisfied. So only when O1 is equal to 1, O2 is equal to 1, O3 is equal to 1 and O4 is equal to 1, that time the point will be in region A. And when O3 is equal to 1, O4 is equal to 1, O5 is equal to 1, O6 is equal to 1, the point will be in region B. But for the point to be in class 1, that is category 1, it can either be in region A or in region B. So please remember what I said. For a point to be in class 1, it has to be either in class A, either in region A or region B. But for it to be in region A, O1, O2, O3, O4 should be equal to 1, and for it to be in region B, O3, O4, O5, O6 should be equal to 1. That is compulsory conditions. So I have to use 2 AND gates, and the output of these 2 AND gates will be combined by using OR gates. Now why? Because it is an option between region A and region B. So it is either the point can lie in region A or in region B. So if the point lies in region A, O1, O2, O3, O4 will be 1. If at all the point lies in region B, O3, O4, O5, O6 will be equal to 1. Both will not be at the same time. Both conditions cannot be satisfying at the same time. So what do we do is that, here what do we do is that this particular neural network, what we have drawn, has to have one more layer, and in which, for it to be in region A, for region A, I have O1, O2, O3 and O4 will be equal to 1, and for region B, O3, O4, O5 and O6 is equal to 1. So I draw another neuron here, second layer of neuron. Okay, and which ones will I connect here? The first, this is for region A and this is for region B. So I can name it as OA and OB. So for the first one, I have to connect O1, O2, O3 and O4. And what gate it should be? It should be an AND gate. And whenever it is an AND gate, what should be the bias which should be given? The bias, if at all it is a 3-input AND gate, the bias has to be minus 2.5. But here it is a 4-input AND gate, so the bias is minus 3.5, slightly less than the number of inputs. So that is what we have seen. So I write this name as OA and the bias is minus 3.5. Similarly, this neuron is OB. I will erase it out from here. And for OB, which are the inputs which are given? O3, O4, O5 and O6. And what is the bias? Again, it is minus 3.5. For obvious reasons, it is an AND gate. So all these weights are all ones. We are not using any other weights. Now, so if at all the condition O1, O2, O3, O4 is equal to 1 is satisfied, then this neuron will get fired. If at all the condition O3, O4, O5, O6 is equal to 1 is satisfied, this neuron will get fired. But both of them cannot get fired at the same time. So, yet we need one more neuron in the last layer, and this has to be an OR gate. So we connect this output OA and OB output to this OR gate, and because it is an OR gate, the bias is how much? Minus 0.5. So the bias is 0.5. So here I write this is a 4-input AND gate. That is the reason the bias is minus 3.5. And this is a OR gate. For any OR gate, 2 input, 3 input, the bias has to be minus 0.5, and then you get the final output here, O. So this is a neural network. This is the classifier which is designed in order to give that particular classification which is shown in that particular diagram. Is that clear? So this problem is done.